Hi everyone, welcome back. There might just be a bit of background noise in the video, so if that annoys you, maybe just turn it down slightly. I'll try and talk a bit louder to sort of drown it out. This is being done at home during the coronavirus distance education, and so I have to compete with people mowing their lawns outside, so apologies if that disrupts you. Anyway, so we're going to finish off this short little bit on polynomials, introduction, with what we call the method of equating coefficients. And equating coefficients is a really good way to factorize polynomials. Okay, and it turns out when we do division of polynomials and factorizing later on, that you can use this in conjunction with other methods to fully factorize a polynomial that has a degree of 3, even a degree of 4 or 5 if you wanted to. Okay, so let's look at this statement here. So two polynomials, p of x and q of x, are said to be equal if and only if their corresponding coefficients are equal. Okay, what does that mean? Well, in this example here, we've got two polynomials of a degree 3, so they're both cubic polynomials. So we have p of x equals some number times x cubed plus some number times x squared plus some number times x plus some constant value. Q of x, same thing. Okay, we've got some number times x cubed plus some number times x squared, there should be a b here, plus some number times x plus some other constant. Okay, now the only way that these two polynomials could be equal to each other is if the coefficients of the corresponding terms are the same. So they're only equal if a3 equals b3, which is what that says here, or if a2 equals b2, which is what that says there, or if a1 equals b1, which is what that says there, and also if the constant terms are equal as well, which is what that says there. Okay, so the only way for two polynomials to be equal to each other is if the coefficients are equal to each other. Okay, and I know that seems kind of obvious, but if you just think about it, we can use this fact to answer a variety of problems. I'm going to show you one of those types of problems here. Okay, so we've got this polynomial p of x equals x cubed plus 3x squared plus 2x plus 1. And in the question it says it can be written like this. Okay, so we can sort of partially factorize it, I guess. We can pull this x minus 2 factor out of it, multiply it by some quadratic, and have a little bit sort of left over, I guess you could say. And our job here is to find the values of b, c, and r. Okay, how do we do that? Well, we know that these two polynomials are the same polynomial. Okay, it's just we can rewrite this one to look like that, but they're the same thing, right? So what I can do is I can set that up like this. I can say x cubed plus 3x squared plus 2x plus 1. This is equal to x minus 2 times x squared plus bx plus c, and then plus some other value at the end there. Okay, so we know that the polynomials are equal to each other. So what we can do is, well, I'm going to expand this right hand side and simplify it as much as I can. So let's expand this. We're going to do x times each of these three terms. So we'll do x times x squared, gives me x cubed. X times bx is just bx squared. X times c is just xc, or cx. And then we can move on to the negative 2. So negative 2 times x squared is minus 2x squared. Negative 2 times bx is minus 2bx. And minus 2 times c is just minus 2c. All right. And then we've expanded all of this, and we've got this plus r stuck on at the end as well. All right. Now what I'm going to do is I'm going to write all the terms in order of descending powers of x, just like we normally do. So x cubed stays as x cubed. There's no other cubes around. We can do bx squared minus 2x squared. So plus bx squared minus 2x squared. Cross them off as we go. We do the x's, so plus cx minus 2bx. And finally, we've got minus 2c plus r. Cool. All right. One more thing that we can do is I can actually factorize pairs of terms that have the same power of x. So we can't do anything with x cubed. That stays as x cubed. But what I can do is I can factor out the x squared, and I can factorize it in the following way. I can write it as plus b minus 2 all times x squared. Okay, if you don't believe me, expand it out, see if you get back what we had up here. Okay, so b times x squared is bx squared, minus 2 times x squared, minus 2x squared. So what we've done is I've just taken out the x squared from both of those terms. Okay, we can do the same thing for the x terms. So I can write this as plus, I'll write x at the end, and what have we got left over? Well, I've got c minus 2b. There we go. And lastly, I mean, both of these terms don't have any x's on them, so I can't really factor anything out. So I'm just going to write it like this, plus minus 2c plus r. Okay? We can't do anything else with this at the moment. But what we can do is we can compare it to the original polynomial that we've had. So this original polynomial is x cubed plus 3x squared plus 2x plus 1. Okay, now we know the polynomials are equal. So that must mean the coefficients of the corresponding terms must be equal. So x cubed equals x cubed, that's fine. We don't have to worry about that, okay? Look at the next one. We've got 3x squared. This term must be equal to that one if the two polynomials are the same thing, right? So that means the coefficient 3 must be equal to the coefficient b minus 2. And so there's a little equation that you can use to work out the value of b. Okay, and we'll do that. We'll add 2 to the other side, you get b equals 5. Awesome. All right, and we keep going in this way, just comparing coefficients or equating coefficients. So we look at the next one, 2 plus 2. Okay, plus 2 has to be the same as c minus 2b. If they're both the coefficient of x and the two polynomials are equal, then the coefficients have to be equal as well. So 2 equals c minus 2b, or c minus 2b equals 2. Okay, now we know what b is. B is 5, so really we've got c minus 2 times 5 equals 2. 2 times 5 is 10. So we've got c minus 10 equals 2. And so c equals 12. Cool. All right, last one is the constant term. So here we've got a constant term of 1. And here we've got a constant term of minus 2c plus r. And we know those two things have to be equal. So we write it out. Minus 2c plus r equals 1. Now from the previous one, we know that c equals 12. So we can write minus 2 times 12 plus r equals 1. And from that, you can work it out yourself, but you'd get r equals 25. Okay, and there we go. We found the values of b, c, and r. Okay, and we've used this method called equating coefficients to compare the two polynomials term by term and equate corresponding coefficients to each other to then get out these little equations that we can use to solve for our unknowns. Okay, and this will pop up from time to time in the next few exercises. But anyway, that's it. That's all I wanted to go through in this last video for introduction to polynomials. In the next video, we're going to look at how we can divide polynomials and look at the method that we use to do it. Okay, it's a little bit long in its process, but it deserves its own set of videos. Okay, we can't just do it in one go. All right, so we'll stop there, and I will see you next time.